says here, the information below represent the minimum temperature in degrees. Hold on. Minimum temperature in degrees Celsius recorded in country A for the first 20 days in a particular month. All right. So for the first, that means we have 20 things here. So for the first 20 days in a particular month, we got those recordings, right? So we're dealing with some statistics now. They want, they said complete the frequency table below using the information above. All right. So we want to complete the frequency table. Already you see that they put in some stuff in there already. So I'm just going to highlight what they have. They talk about at 21, you see they have 1 and they put the 1 stroke. 24, there was 3 and they have the tally for it. So what we're going to do is to do a tally as well as the frequency. I'm talking about 23 now. Normally what I'm going to do, I'm going to cross them off when I go through them. Let me use black when I cross off. 23, you see 1, 2, 3, 4, 5. So it helps to minimize error. So 23 is 5. 1, 2, 3, 4, cross 5. And you put our 5 there. 25 now. 25. 1, 2, 3, 4, 5, 6, 7, 8. So I'm seeing 8 25s. 1, 2, 3, 4, 5. 1, 2, 3, 8. 26. I'm seeing 1, 2, 26. 1, 2, and we put our 2. All right, and then you can see the rest. The 3 24s and 122 and 121. So you're seeing what they did. All right, so we would have completed the table there and we get 2 marks just to complete that. The question says determine the median temperature. So the median temperature is actually, we can find the position of the median when we have the table. Originally, we would have lined up the raw data in some order, ascending or descending order, and pick the one in the middle. But what you don't want to do is to rewrite these. When you have a table already, what you want to do is to have your total frequency. And it was said here that we're dealing with 20 days, right? So if you should add up all of your frequency, you will get 20, all right? So you add up a frequency, you get 20. So if you add 1 to the 20 and divide it by 2, it's going to help you to find a position where the median lies, right? So 21 divided by 2 is 10.5. All right. So basically, you're kind of going 10.5, like you're going for the 11th term. All right. So the median is at the 11th term, 10.5. So I'm going to do a cumulative check. So I'm going to check up and down the table by adding. And whenever I reach 10.5 or more, I'll stop. Right. For example, so let's say I'm going down the table, down this way. So we have 1 plus 1, that is 2, plus 5, that's 7, plus 3, that's 10. Then when I add 1 more, I would have passed 10.5. So this is telling me that this is somewhere where the median is. So I'm going to stop. So I'm pointing at 25 because the median is a temperature, right? And then now I'm going to have to do a cumulative check going up the table, up, going that way. So we have 2 plus 8, 10, not there yet. And by the time I add 3, I reach, right? So this is telling us that we have to pick up 24 as well. So what it means that 25 and 24 are actually in the middle together. And you know that when you have 2 numbers in the middle and you want the median, you have to first add them and divide by 2. So in this case, our median is 24 plus 25. We divide that by 2 and we will get 24.5 as the median temperature, right? So it's 24.5 degrees Celsius. And that is the median, right? So let me write it on the line, 24.5 degrees Celsius, and that is our median temperature. Next question says, calculate the mean temperature for the 20-day period. The mean temperature is what you call statistical average, right? There's a formula for it that says that the mean, I'm going to call it X bar, stands for mean, is the sum of the fx column divided by the sum of f. In other words, I'm going to create fx column, right? So I have frequency refers to f, and fx, x would have been your values that you have here. The temperature, that's the x, and f is from the frequency. So I want to create that fx column right here. We're going to multiply those things to get that quickly. So we're talking about, we could say 1 times 21. That's going to give us 21. And then we have 1 times 22. That gives us 22. And then 5 times 23, 115. And then what we have, 3 times 24, that looks like about 72. All right. 8 times 25, and that's like about 200. So 8 times 25 is about 200. And lastly, 2 times 26, and that is 52. So these values that I have here, 21, 22, 115, 72, 200, and 52, 1, 2, 3, 4, 5, 6. They will be added to give a total, and we need to total that quickly. 21 plus 22 plus 115 plus 72 plus 200 plus 52, and that's a total of 482. So the fx will give us 482. So let's go back. So the formula, as it says, which is 482 over 20, because 20 divide that by 20, 482 divide that by 20, and I am getting 24.1 degrees Celsius. And this is the average temperature over that time. So generally speaking, the temperature would have been close to that on any randomly selected time. And says the diagram below represents the cross section of 2 circular pizza, A and B. The pizza are similar but vary. So they are similar but vary in size. You could see pizza A has a diameter of 15 and pizza B has a diameter of 30. All right, so basically we have some information equal to 30 here, or centimeters, right? And this diameter over here is 15 centimeters. All right. All right, let's see what they want. It says determine by calculation, right? So determine by calculation if pizza B is twice the size of pizza A. Well, if we're going to do that, we're going to have to find the area of both. So let us work on the area of both. The area of all circle is pi r squared. So we're talking about pizza A over here. So let us see if they give me a pi. If not, I'll just use mine. So pi r squared, we're talking about 3.14 times r. R is a half of the diameter. So r in this case is 7.5, half of 15. So times 7.5 square. So we're talking about 3.14 times 7.5 square. And this one is 176.63 cm square. So this is the area of the small pizza A. So pizza A has an area of 176. All right, so let us go for pizza B. All right, so I could work out pizza B, maybe right beside it here. So pizza B Same formula, pi r square, where pi is 3.14 times 15 for this radius. Radius is half of the diameter. So it is 15, so 15 square. So we're talking about 3.14 times 15 square. And we have 706.5 cm square. So the area of pizza B is 706.5. So we want to determine now if pizza B is twice. If pizza B is twice the size of it, it's more than twice the size of it. All right. So no, we have to say no to that question because it's actually more than size. So we have to respond to the question. So no. All right. We want to say that, listen, pizza B is more than twice pizza A size, right? Let me write it better. All right. All right. Pizza B is cut into 5. All right. So I'm working with my pizza B. It has an area of 706.5 A, and we have 176. All right, so we could write that this pizza A is sold for $9.95. All right, it's sold for $9.95. Now we're going to cut up this. So we want to know the better buy. So we're going to have to work out pizza B. All right, we're going to have to work out what goes on with pizza B. So it was cut up into 5 equal pieces and then sold at a particular. So what we want to do is to divide this 706.5. So we want to divide this into 5 equal pieces. Add that into 5. Here it is now. When we cut pizza B, all right, which is a 706 point, this is a point right here, 706.5 into 5 equal pieces, we're actually getting the fact that it's 141.3 cm square for a slice. But for one slice, it's $6 something. So we're going to have to work out what $1 gives. We want to know what $1 gives for both, and then that will tell us. So we're going to put the money underneath. For example, this 141.3, we want to divide this by $6.95 so that we could know what $1, how much centimeter square $1 actually gives. So let's do that. So 6.95 into itself one time, and this is referring to $1 at the bottom. So it's going to now clarify what's up at the top for that. All right, so we're getting 20.3, all right, cm square. So what this means, that $1 gives for pizza B, $1 gives 20.3 centimeter square of pizza to be eaten. Now, this one, now we're going to have to just divide up this 176.63, divide this by the cost that it was sold for. So $9.95 going to itself, that's one time, that's $1 at the bottom. So 176.63 divided by 9.95, and we're actually getting 17.8 cm square for $1 here. So you could see that over here with pizza B, I'm getting more for $1 because I'm getting 20.3 centimeter square for $1, while at pizza A, I'm actually getting 17.8. So the better buy is Pizza B. I'm getting more for my money.